All right, so today we're gonna talk about El Niño, um, lecture 17 according to the syllabus. Is one of the um, elements from the module of water and environment. So El Niño, what is called now the ENSO phenomena, because it happened to be that in the beginning it was talk about El Niño just like a normal event, and then we realized there was something in the opposite direction called La Niña. You know, those are in Spanish, the boy and the girl, and it seems to be that those two things happen to be in connection. So the better term to be defined now is prefer to use the acronym ENSO, INSO, because it's defining the El Niño Southern Oscillation. And it really represents what happens. It's an oscillation between an event that happens to be like what we see here, El Niño. It's a warm water event accumulated in the western part of South America, eastern part of the Pacific Ocean. And during La Niña, it's like a normal or an exacerbated normal condition. So this is La Niña, and this is El Niño. And the two actually are part of what is called the ENSO phenomena. So we're going to go and try to explain this in a better way. This is a phenomena better observed in this equatorial zone. In particular, was observed first in the eastern part of the Pacific or western part of the South American continent. What we see normal conditions, what we're going to define now, normal condition, what normally happens in that region, we do have, first of all, very strong trade winds. And the trade winds are blowing from the east to the west. In fact, it's more like a southeast to northwest than anything else. But those are the trades. And it happens we have another counterpart in the north, and these are the northern trades, these are the southern trades, and that is actually driving a very important current we call the equatorial current. Those two are actually producing a flow of water to the west in a continuous way. So this flowing of water is producing an important effect that is making the nutrients from the bottom rise up in something we call upwelling. And that is producing an unusual abundance of nutrients, and that is consequentially producing an important blooming of phytoplankton. So nutrients, proper conditions, phytoplankton very abundant, and phytoplankton obviously is something that is making zooplankton that feed on phytoplankton become also very abundant. These two things are actually quite good to produce a really good biomass to be considered in the fishing area. So fishing and the industry of fishing happen to be quite well during normal conditions. Okay, so you're going to see that is absolutely the opposite when we go into the El Niño conditions. Now, just a reminder about what are these things that we mentioned. The trade winds. Trade winds are produced by the Hadley cell in the north here, another Hadley cell in the south there too, and in the movement of this convection cell that we see, air is coming up, going up, and making a lot of precipitation in that area. So rain is quite prevalent in that place. And since this is moving from the north to the south, and from the south to the north, getting together in that section, and affected by Coriolis because Earth is rotating, and the effect of Coriolis is making those winds to deflect, to the right, and to deflect to the left in the south. Coriolis does that. A deflection to the right in the northern hemisphere, and a deflection to the left in the southern hemisphere. This is something that you probably know already, but Coriolis is only working when we have movement of larger volumes of mass, in this case air or water, from one region to another. And got to be a fairly large distance in order to be observed. So because of that, we do have these superficial winds in here called the northeast trade winds. And by the same token, we have the southeast trade winds in the south. These blue arrows in here are showing more or less the direction of the trade winds in both hemispheres. So they are between 10, 15 degrees north and 0 in the equatorial line, and 15 degrees south or negative if you want. So the trade winds are really making normal conditions work. And this is what we see there. So if the wind is taking this superficial water away from the coast, let's suppose this is the Peruvian coast, looking obviously in a direction north. So we're going to see this water is moving away to the west, and then the replenishing of the water from the bottom happens naturally. That water is cold, and it's also full of nutrients because it happens to be in contact with the bottom of the ocean. So we do have here perfect condition for those blooms of phytoplankton and for the zooplankton, the fish, to take advantage of that. So that normally happens, those normal conditions. Oops, sorry. You know, a typical illustration, this is coming from a textbook from oceanography, that everyone in this set of levels, if you want, enjoy a good time when we have phytoplankton, especially, well, more or less we can say this is phytoplankton in here. Phytoplankton feeds into the next level, zooplankton, and then small fish feed on them, and also very large animals do feed in those levels because they require much more amount of food than the others, and we go on into the different levels. In fact, this is what we normally call the food web. We don't use anymore the food chain, that is a linear thing. So phytoplankton is doing well, everybody else is doing well. And the opposite is true. You see, phytoplankton is no longer produced because if we go into this situation here, what we have in the condition for producing good amount of phytoplankton, we need light. This is light. We do have water, and we have CO2. All these three things are, but then we have a limiting thing, which are the nutrients. If nutrients are not available, productivity doesn't happen. So if this upwelling is no longer working because the trade winds are not blowing properly or they are weak, the productivity drops dramatically, I should say. Well, we can measure productivity today using satellite images. In particular, here in this product we're seeing is a full composite satellite imaging. We see the red marking places where photosynthesis happens. This is not real color. In photosynthesis may actually affect the water to become red, but not always. In fact, in here we are measuring chlorophyll levels by filtering the light. So all these red areas are showing places where we have high productivity. Here, here, around Antarctica. And remarkably, we should mention also that all this area here, the open ocean, if you will, got nothing, no productivity. Why? Well, the conditions are perfect, there's plenty of light, the temperature is fine, CO2 is available through mixing with the atmosphere. What happened in the center of the ocean, the water is blue, and it's blue because there's not really any nutrient to feed the phytoplankton. So the best places to go fishing, commercially or otherwise, in a coastal area like this in here, where we do have upwelling. Now, going into the subject at hand today, El Niño conditions. So we're going to use one particular year, 1997, where El Niño was unusually high. The conditions were such that we have in here a deviation of the temperature in the upper part of the ocean of as much as 4 or 5 Celsius degrees. And that's a lot. Celsius degrees are about 1/3. I mean, a Fahrenheit is about 1/3 of a Celsius, but it's not really quite exactly like that. But what we see here, remarkably, we see this part in here very warm, and warmer waters in here too, and in here too. So all that is a departure of the normal that is 0 here. In fact, if we do have all this area covered by hot water, that's going to be effectively acting as a lid on top of the water, stopping the nutrients from reaching the upper part. So when we have this situation in here, there's no phytoplankton, there's no zooplankton, and any animal that is feeding on those either move away somewhere else or die. So 4 Celsius degrees warmer than normal is really strong El Niño. And we see here, this is representing Peruvian fishing during the years from 1960s to 1990s. And what we see here, the amount of fish that was produced during those years in millions of tons was increasingly going higher, like we see here, to this point. And then we do have one of the strongest El Niño in record, and the productivity drop like 10 times. And then there was some recovery, and again, no chance to recover. Another El Niño coming in here in the 1985 or so, and then no production fish during that period of time, nothing. So if you are basing your economy in the fishing industry, this is a complete disaster. So much actually, they never recover to the actual levels, to the previous levels. This is a combined El Niño plus a lack of sustainably fishing. Once they deplete the resource, the coming back is quite difficult. So it is important. Now, to define El Niño in a few words, I'll say the most important thing you have to look is for the trade winds to be weaker or stop altogether. So when that happens, there's no more wind blowing in the northwest direction, the flow of water stops, and then the temperature rise, and the nutrients are no longer reaching the place. Why is called El Niño? Well, El Niño is because it happens around Christmas season. And you know, in English translation should be the child, making allusion to the Christmas season where Christ was born. So that's the reason it was named El Niño. Now, how long it lasts, we don't really know for sure, but it varies between 12, 1 full year, a year and a half. And how long it happens, how often it happens, it may be 2, it may be 7 years, so we don't really know. That's something that we don't really like, obviously, because we cannot really make a good prediction. See, for example, here we do have some records after this disaster, El Niño, that happens in 1998. We do have some records. What we see here is El Niño, January to March 1998, and see here all the departures of temperature. This is actually absolute temperature, sorry, in Celsius. 30 degrees Celsius, 29, and so on. So see here a big pool of warm water in the Peruvian coastal area and offshore coast of Peru. Now this is departures, and it's a little easier to see here. This is away from normal, and we see here it's about 3 to 4 Celsius degrees more. And interestingly enough, if we look here, the temperature is less than normal. Why that happened? Well, we're going to see. In general, during a normal time, the accumulation of warm water happens in the western area. But when El Niño is in full blown, we're going to see that thing moving west. So, consequences of El Niño are not just what happened in the South American coast, but also it's affecting the whole area here. Australia and the Indonesian islands are greatly affected. So we're going to see about that. During La Niña, which is like a normal, but worst, we see here the temperatures are normal here and warmer here, warmer than normal. You can see it in here, see. Lower temperatures than normal in all this area and warmer temperatures than normal in here. So it's a pair of things that happens as we see. The southern oscillation, Niño Niña, is essentially ruled by the strength of the trade winds, but it's also something can be observed by a variation in the pressure between two different places, central and western tropical Pacific. Like this. So here, we may actually measure the pressure here and measure the pressure here and see there that when we see a variation in positive or negative gradient, is a reason we may actually go into El Niño. Now, what it got to do with low pressure, high pressure? Well, this is essentially a very simplistic view where we see high pressure means the density of the air is very high, and when we have that situation, air is moving away. And it's moving away, obviously, it's moving away a long distance. We're going to see this being deflected to the right as Coriolis ruling. And if we see the opposite, lower pressure in here, it means essentially going up due to high temperature or some other variables. And you're going to see there now the opposite. Winds are going in from all over the place. And that also follows Coriolis. Being deflected, as Coriolis rule, to the right. So what we're going to do now is try to see what happened with these pressures or pressure anomalies that we made. See El Niño here, 1998, the same one we just mentioned with the departure of normal temperatures in the upper part of the ocean. So what we see during El Niño, what we see is this place in here, remarkably, is very low pressure. And this place in here is high pressure. All right. And during La Niña, we see the opposite. High pressure here, low pressure here. So it seems to be that there are something easy to observe happening by observing the pressure here and the pressure here. So if we see a positive or negative value between these two levels, these two places, can actually make a prediction about what happened. So what we do with this Souther oscillation index, that's the name of that pressure gradient, we measure the difference between Tahiti and Darwin, which is in Australia, obviously. I forgot to mention. Sorry. So Tahiti is about this area here, and Darwin is more or less in this place here. So that's where the measurement happens. And we measure it, and looking into that difference, we see that it's actually producing a quite consistent correlation between the phenomena Niño right away. So we see here during the years 1990, we see here, that's 1998 or so, we do have an El Niño forming. And the pressure index is negative, meaning we do have less pressure in Darwin. Yes, we have less pressure in Darwin than in Tahiti, and vice versa. So this Souther oscillation index is something we start using it right now to predict El Niño event. Now, all in all, we do see convection events in the planet. The first one, and we're familiar with this, is the Hadley circulation. Hadley circulation happens from the north to the south, going up and returning, Hadley cell in the north, and from the south to the north and returning in the Hadley cell in the south. So that's latitudinal. It means we use our previous graphic in here. Hadley cells are working here, right, in this direction. So it goes south, up, and south again, and goes north, up, and south again in the upper part. That's latitudinal direction. Now we're going to see something that goes from this direction into this direction, or from this direction to this direction. That's a longitudinal circulation cell, and it's called the Walker cell. The Walker circulation cell is going from east to west or west to east. It's converted to and is essentially produced by the SST anomalies, sea surface temperature anomalies. And it's what we see happening. The Hadley circulation, again here. So the Walker circulation works like this. What is this? Well, this is South America here, equatorial line, Peru here, Ecuador more or less in this area here, and this is Australia, New Guinea, and all those beautiful places. But what we see here now is a low pressure area here. Low pressure, air goes in that way and rise, and we do have precipitation there. So when that happens, we do see here a high pressure area, low temperature in the water here, high temperature in the water here. This is the typical Niña phase. I can actually say normal. So this is good, right? We like it. Why? Well, because in this place where it never rains, it doesn't rain, you know, people live in those places are always complaining because it doesn't rain, but if it rains too much, nobody like it. But here it rains a lot, and it's all right. We do have a lot of precipitation. This area here, in fact, are rainforest, so rain is welcome. And the trade winds blow quite well in this direction and this direction. Upwelling happens, fish are happy and all good. So this is La Niña phase or normal. Now, what happens if we start seeing changes? Now, what happens if this is now true? We do see now a low pressure here. So you're going to start seeing a circulation that goes from here in this direction, and precipitation happens way more west, reaching even the desertic areas of South America, and this place in here, no rain, dry. So this is El Niño. El Niño is essentially awakening of the trades, are no longer blowing or blowing very, very slowly. Displacement of the Walker circulation to the west, to the east, I should say, sorry, to the east, and is changing the normal into a completely different set of conditions. So, if we have to monitor El Niño Niña, or the ENSO, if you want, much better saying, is we start, in fact, this was the original way, to monitor the temperature in the ocean. Sea surface temperature. And then we go into the looking into the difference between the pressure, the atmospheric pressure in one place, in Tahiti, and the atmospheric pressure in Darwin, and come out with another term, the Southern Oscillation Index. We already talked about that. And we see also trade winds. Trade winds are strong, well, that's fine. We have a Niña or normal, and if the trade winds are weaker, we do go into El Niño event. So this is something we already talked to. Now, the other thing we can see is changes in the sea level. And these are changes in the sea level not really produced by anything else but this phenomena. When we do see the trade winds decrease, we do see an increase in the sea level in the coastal area. So warmer and higher, but not by much. You got to understand this is in the order of a few centimeters, no more than that. And then we can measure the depth of the thermocline. Thermocline in general is something we define like this. This is the sea surface in here. Temperature is higher in there, and as we go deeper, a few meters, and then quickly decrease temperature. This is temperature. That's also depth. There's a point where it's no longer such a quick decrease in temperature. This area here is called the thermocline. So if this line is higher and lower, it got also to do with this phenomena. But it's much more difficult to measure. So, the elevation of the sea, how high is the water, and how deep is the thermocline, is illustrated by this particular animation here. You see, variation of the SST and sea level during El Niño La Niña. You see here in color, what we see is the difference of sea surface temperature, and as we see this graphic in here in the vertical from 0 to 20 and from 0 to minus 20 centimeters. So it goes up and down depending where we are. What we see here is an oscillation between, I used to have in here a window showing how it changes, but you obviously see the higher temperature goes up and the lower temperature goes down. So during El Niño we see high level, and during the La Niña we see low level, physically representing elevation of the sea. But again, variation between 20 to minus 20 centimeters is not really much. Same thing here. Now what we see here is the thermocline. How it changes depending on where we are. Temperature again measured by this color in here, 31 Celsius, 19 and 7, and we see here in this point is where the thermocline is, and you see a little variation in the elevation or the depth of the thermocline depending where we are. So as you see, we've been measuring these things in a complete way. Another view, this is actually a little more, including longitudes farther away from the coastal area. And see, right here, the arrows are representing the trades. So during El Niño, the trades are going very much anywhere, and during La Niña, they're well-defined due west all the time. But this is all good and fine, all these models, all these animations, how we come out with those values to make the model. Well, by using this. This is a buoy. These buoys, I know it's not really only one, these buoys are concentrated in the central Pacific in a band that goes all the way from coastal Peru all the way to Australia. And they're measuring temperature, measure atmospheric pressure, measure temperature in the water, depending on where we go. These things are more into the bottom of the sea, so we measure values 500 meters, 700 meters, and even deeper. And we see here also temperature in the very top of the water, and we do also measure wind direction. So each one of these buoys is taking data continuously and send that to a satellite, compile, and use. So this is called the TAO, Triton Array Observation System. So if you do want to see it, it's a way to see real data, and actually you got to go to this link in here, and you get a real-time observation of the data being produced right now. So this is produced by NOAA, National Oceanic Atmospheric Administration, and this is the array TAO, TAO Triton Pacific. Now we do have something in the Indian Ocean, we have something in the Atlantic, all different things. If you come to see this buoy in here, each one of these square blue dots represent a particular buoy. You can click on it. Well, this used to be, and you can see the data from that. Well, you have time to do it, but you know, all the data is available. If you're going to see what is going on, you can actually go and do it. So, quite interesting. So, I really recommend you to play with this because it's real data. Now, right here we see most of the TAO with another set of Australia and some other produced by Japan. JAMSTEC is Japan Atmospheric and Marine Administration. All these data are compiled and producing all these models and things. So a little history about how we start monitoring these things is very much showing the way we humans do things. So the first thing we did actually go to this place in here and observe what happened. Well, because, you know, this is Peru, and that's where El Niño happens, so we go close and look. And then, well, we start looking also in the upper part of the region, number 2, Niño 2. It defined that region as such. And then we extend the region to Niño 3, all the way to the central part of the Pacific, more or less in this part in here. And then, not really happy with that, we go all the way to the Australian coastal area with Niño 4. Well, find out the best thing to do to monitor the Niño effect is do this here. What is called now the Niño 3.4. That's the place that we should monitor to see variations in the SST or sea surface temperature or the Southern Oscillation Index. So, an explanation here about what we just talked about it. So Niño 3.4 overlaps part of 3 and 4, obviously, and is the best region to monitor for predictions. We have a video here with a quick explanation by some important scientists. It's not really taking more than 2 minutes, so we're going to let you do it and enjoy it.
El Niño is the warm water phase of the El Niño Southern Oscillation, the most influential climate pattern used in seasonal forecasting.
During El Niño, ocean temperatures over the Pacific begin to warm up. Surface winds weaken and rainfall increases over the central or eastern Pacific while decreasing over Indonesia. Warmer oceanic and atmospheric conditions in the central and eastern Pacific fuel the jet stream. Because the central and eastern Pacific is warmer than normal during an El Niño, the jet shifts eastward with this energy source. A stronger eastward shifted jet stream favors low pressure in the Gulf of Alaska, higher pressure over western Canada, and lower pressure over the southeastern United States. This type of influence from one region to another over large parts of the globe is referred to as a teleconnection. During winter, El Niño is generally associated with wetter than average conditions across the southern tier and drier than average conditions in the Pacific Northwest, the Northern Rockies, and the Ohio Valley. We typically observe below average temperatures across the southeastern United States and warmer than average conditions over the northern part of the country.
Weather is what we experience every day. But remember, climate predictions based on El Niño tell us what kind of weather to expect on average and over a long period of time. From NOAA's Climate Prediction Center, I'm Ned Gardner.
So, hope you enjoyed that video. It's always convenient to see all these different views by different scientists. I pick with a different accent, obviously. So, what we have here is something, the compilation of that region, 3.4, if you want. We see here the first one is ocean temperature departures in Celsius. And we see here, obviously, changes in the positive in red, marked in red, and changes in the negative, marked in blue. And so these are Niño, and sometimes El Niño is not really well defined, or the effects are less stronger. And then what we see here, between Tahiti and Darwin, we do see the Southern Oscillation Index. And we see the negative value here for Tahiti Darwin means same thing as this. So this correlates quite well. That's El Niño. And La Niña too, right here. So all these values are representing that what we start seeing first with the sea surface temperature departures and the Southern Oscillation Index are happening quite at the same time. Difference is, it's much easier to measure the Southern Oscillation Index because we measure just atmospheric pressure, and we don't have to go into the water and measure the water and all that. So this is from 1998 actually, and it's interesting because we didn't really know was going on, and everybody was talking about El Niño for everything. And everybody was blaming El Niño for this. Like the cartoon is suggesting, even the kid is taking advantage of that. But anyway, obviously, being such an important change in the oceanic conditions in such a large area, we do have changes in the weather. We may actually say weather instead of climate. Climate is much more long-term, and probably not quite sure it should be called climate changes or climate impact in El Niño. Weather is something that happens right now, and climate is something that happens over a year or partially sections of the year. So what we see here, during an El Niño event, what we see here during December, February, obviously got to do with the seasons. We see changes in this area here to become drier than it was, drier and warm. For us, we do see much wet and cold in this in our region. See, South America too. The northern part of the North American continent, Canadian and Alaskan areas are also having an unusual warmer period for December, February. What happened during June, August, same thing too. We see a weather than normal area in this part in here, dry and warm in the tropical sections of the Caribbean and North South America. And that is something is important to make a prediction about. During La Niña, normal conditions are fine, but stronger than normal. So we see here colder than normal in this North American section, drier and warmer for us in Texas and the Southwest, and in the June, August, we see here cold and wet. Wet and cold in this area. So these things are more or less what we observed during these events. Emphasizing about what happened to us during La Niña is we expect to have drier in the south central part of the United States, drier winter patterns, colder than normal in the Canadian north part of the United States, and more precipitation in the northwest area. Now, during winter in El Niño, we do see kind of the opposite, warmer in the area that used to be colder, and we do have colder climates in the southwest and wetter climates than normal in the southwest of United States and Mexico. It's all depending also affected by the jet stream that is going further south during El Niño and going a little higher during the La Niña. So, very important. Now, what we have right now? What we have now is La Niña. According to this view here, May 22, La Niña is well defined here. This is the equatorial line. You see here is cold water all the way here, warmer water in here, so no precipitation here, precipitation and warmer climates in here. So that's what is going on right now. Some of the things we can see looking back in history, in recent history I should say, during 72, 73, El Niño event was big, and that's the thing. El Niño event, the Niña events can be extremely strong or weak, at least even not really easy to notice in places. El Niño was big, but was not the highest in record. And we do have problem with production of food. It got a problem for the Russians with the wheat crop. So 82, 83 was big one of the El Niño most important. It was the largest until 1998, which is even higher than this. Got floods, problems with droughts in other places. So it changed the pattern of precipitation. Places where it never rains, it does. Places where it rains all the time, it doesn't. So, people are not happy about it. We do see flooding in Peru. We see droughts in the tropical forests of Indonesia, Australia, North and South Africa. So nobody is happy with that. A few others. A long El Niño event. This one lasted like 5 years, all in all. The strongest El Niño was 97, 98. Didn't last much that 1 year, but it was very, very strong in all these parameters that we measure. Now the question is, when the next El Niño will be? Well, we have to use the parameter we now measure, the Southern Oscillation Index and the sea surface temperature in the 3-4 region. And normally NOAA, which is the leading organization that take care of this for the whole world, I should say, is predicting when it's going to happen and how it's supposed to be. But like always, a prediction in the future is always hard. But what we see here in the largest El Niño event ever recorded is essentially bad time for this region, dry and warm. And this is in December, February, and in June, August, it's still dry and cold. So, big problem for these areas in here. They have strong fires and droughts during that time. And here, at the opposite, you go to the Peruvian coastal area, it never rains, and it does rain. And there's no vegetation to hold the soil, and so everything is going down. Big problem with floods and mud flows and all those things are disaster happenings. But here we have a complete list of the 20th century and what happened during El Niño, during La Niña, and you happen to be interested in this, which is quite interesting. You see here some interesting points during the moment of worldwide events, like the Second World War. You see here during La Niña, very cold conditions in Russia happen to be more or less aligned with these two events. So there are some factors in here that can actually be explained. Now, if we go into prehistorical studies and we happen to talk about what happened with the pre-Columbian cultures, we see an indication of a big event in Peru, in the Mochi culture. In this valley here, it happened to be one of the largest non-Inca cultures that was later dominated by the Incas. This population in here were affected by at least 7 different events of floods attributed to these mega El Niño events. And it can be recorded in time, as we see here in this stratigraphic archaeological section, and see here the different events that were flooding the valley where these pre-Columbian cultures were living. So it's an important factor now in the consideration of what was going on in the abandonment of some of these city cultures. Well, anyway, to finish this, in conclusion, we have this. The ENSO, or El Niño Southern Oscillation, is cyclic. It's affecting the atmosphere, obviously, and also the ocean. We do see 2 phases, El Niño, La Niña, and in between we have what we may call the normal. It may happen in one event of El Niño, and then normal And then El Niño again. It doesn't really have to be an oscillation between Niño and Niña at all. It happens when the conditions are right for one or for the other. So don't get confused with that. It's not really a cyclic thing. We can have several consecutive El Niño or La Niña without having the other. So now, the other thing we know is these are affecting the climate very much in the whole world, and particularly in the Pacific area more than anything. Now, what's going to happen when we have global warming into the situation? We already have it, so you know what's going to happen with the El Niño southern oscillation. Well, we'll see. Some references in here, some web resources. By all means, I recommend you to go to NOAA for anything related to El Niño. It's a very good source, up to date, and it's quite important. But in fact, just rounding up, in conclusion, if you had to define El Niño southern oscillation, this is well defined by the trade winds. The trade winds are stopping or being weak, El Niño will be happening. Anyway, so that's it. Thank you for your attention. By all means, check those web resources which are invaluable for these studies. And next time, we're going to talk about something in the same group of ideas, environmental and climate changes. We're going to talk about glaciers and climate change in Latin America. All right? Thank you very much.